So the video we see here is one of the tagged downtime events for our Haas4 CNC machine. And first watch through, it looks, fairly normal. Out of the ordinary. We wouldn't, be targeting this as an area to improve upon. But, so he's loading in the part now. It's going to get machined. Then he removes the part from the CNC machine. And if we play the video again,
let's see.
Yeah.
I think here, right?
Right here, he's blowing off the fixture with an air gun to remove just aluminum shavings. It's a very precise part, and so if there's a couple points on the fixture where if we get debris, it'll throw off the part, the scrap part. So keeping the fixture clean is a priority. And that fixture, that blowing off event right there, adds 20 seconds to the cycle time, and that happens roughly every 4 cycles. This orange bin here we see in the graph. This graph is showing all of the tagged minor stoppage events. And the frequency of each one. So the first one, the orange one, that's fixture cleaning, and the second one, the red bin, those are quality checks. Both of these kind of relate to quality checks, and the goal here is not to remove those events. We all obviously want to keep our quality checks. We want to keep cleaning the fixture, but is there a way we can do that without adding to our cycle time? So going back to the fixture cleaning, 20 seconds every 4 cycles. That's roughly 5 seconds additional time per cycle on average. And we run an 80-second cycle. So reducing that 80-second cycle by 5 seconds, that's a 6% reduction in cycle time. Similar with the quality checks. On average, it's 34 seconds additional cycle time every 10 cycles. So that's another 3.4 seconds we could reduce the cycle time by. Combining those together, if we were to eliminate those 2 minor stoppage events, we would reduce the overall cycle time by 10%. So 80 seconds down to 72 seconds.
Yeah. In this case, reducing cycle time for 10% can lead to a lot of productivity gain, I guess. What are we in the point of the gains for the company? I think we have it here.
Yeah, for this machine, running 5 days a week, 24 hours a day, you could see an additional $200,000.
$200,000, yeah. So there are like fixture cleaning more than 600 times happening in a shift, and you also have this quality checks and also other root causes that you have from the downtime, but without coming to the other ones, only from the cuts that you can make from the fixture cleaning and quality checks, you would be able to gain $200,000 for that machine only, right?
Yes, that is correct.
Perfect.
Sarah, what's really interesting about that is that this is very common in things that we see where it's very easy for people to just assume that certain processes can't be optimized, and the things that make up very small periods of time are not really thought about, in spite of the fact they happen with a very high frequency, right? And so we see this all the time where people are looking past opportunities all day, every day, to be able to save money simply because they don't think about it the way that the AI model does, and saying, no, let's aggregate this up in terms of time and value, and let's make sure that we do focus on that. And as you can see, it adds up to a substantial amount for any business. And keep in mind, this is just one portion of a work cell for Caleb.
Yeah, exactly. It also gives you some kind of visibility in terms of the, I think, the other points like scrap and costs, right? Could you also mention a little bit about that?
Yeah. So on this cell, we're actually looking at 2 control points. So we're monitoring cycle time based on the andon light on top of the machine, and then we are also doing scrap counting. And so on our machining side of our processes, the Khenda system is going to be the sole point for process monitoring and scrap counting and production numbers and everything. So, yeah.
Yeah. And previously, how was your scrap counting process? How were you able to get that data?
Our scrap counting currently is tricky. We don't have it's all manually reported by operators, and so there is a kind of, it's not an incentive, but
paper-wise, I guess, right?
a lot of the scrap is underreported, to the point where we'll finish production in die-cast, we'll CNC the machine, or all the parts that we have die-casted, and we end up 500 parts short of the production numbers that we wanted to hit there. So that's the challenge we're currently trying to solve, and we want to use the Khenda vision system to solve that problem.
Yeah, so you are kind of utilizing the system in terms of downtime analysis capability, but in terms of visibility point of view, otherwise you would have, I think, a little bit of delayed information and not trackable information. Now you are able to track that information, base your improvement, base your decisions for improvements to that data, and actually measure have the capability measure its impact. So it's kind of like a continuous improvement journey. It adds up. Let's talk a little bit about the benefits of the system too. So if you would like to add something here, everybody, feel free to do so. Yeah. I think in here is that we have, if we focus on one cell, let's go from there. If we focus on one cell, we have improved the machine and efficiency and OEE. And from your example, Caleb, we reduced the cycle time for 10%. And for only that machine, we reached 200K productivity gain, but we are still on the same machine. So what if we integrate this for the whole factory? Then we are starting to talk about millions, even in the medium-sized manufacturers, I think. So here we can like summarize the benefits of this. I want to also ask about a little bit bigger picture, since we are zooming out, because I know that Caleb, in you and SUS manufacturing, you've been working hard to create your digital transformation roadmap, and I want to understand where this locates into that.
Yeah, it's a great question. So Khenda is going to be the only point of data collection for our production monitoring system for our machining centers. So the entire machining side of our business is going to be monitored by Khenda alone. We're not going to be collecting, or we're not going to be connecting to those CNC machines and pulling data out of them. It'll be purely through cameras.
Right, yeah.
And so we'll get production data from that. We'll get scrap counting from the Khenda system. We'll get rate performance metrics, and that'll all be tied into our database. Currently, our database is it's a SQL database. We access it through Microsoft Access. And so then, on top of the production data, we'll get downtime analysis, continuous improvement through the minor stoppage detection and tagging. That'll be a key feature that we'll implement as well. Another thing that we didn't touch on, or I didn't touch on it, but the inspection verification. Some of our customers require, like, that quality check happens every 10 parts. We could easily, just by adding another control point, which is, that's just in the software, it's not even another camera, detect, oh, this quality check happened, and we can tag that, track that as well, and provide that to our customers as verification. And Khenda is super easy to get all this functionality out of, just, with laptop and a camera. Our system is going to be we'll have an IPC and everything, but yeah, it's easy to get all this data from that. And then on our die casting side, Khenda will be incorporated with a variety of other data sources in our die casting process. So it'll supplement PLC data, furnace temperature data, visit track, shop profile data, pressure data, just everything we're pulling from there. Khenda will be combined with it and supplement it. It'll provide additional insights paired with all that data to help with troubleshooting, downtime events, and so on. And the Khenda data is all historized, so it makes it very easy to group with other data sources.
So Sarah, one of the things I'd like to add to what Caleb is talking about is that he's going to actually have a system that is connected to his SCADA layer, which you guys use Ignition. And Ignition is a great platform for being able to gather other data, the likes of which Caleb was just talking about. And the great news part of that story is that Khenda has built-in APIs to be able to link all that data together into a single version of the truth, or a data fabric, if you will, to then create the contextualization for that data to figure out where to be able to spend their efforts, right? And so one of the things that I think is really beneficial, and I want to speak to one of the comments from one of the viewers out there, is that this isn't about replacing the classic industrial engineer. This is about enabling people like Caleb to effectively do his regular job and become an industrial engineer by exposing data to him in a way that before really just wasn't possible. And so it really becomes additive. You're starting to upskill the layer of capability within the organization and starting to connect the different data sets so that they can start to drive the business forward.
Yeah. And one of the data sets I think could be a bill of materials. I also see that in the comments, because since Khenda is able to integrate with other systems, I think those type of information can be linked with this information, right? One of the parts yeah, thanks. And one of the parts that Caleb mentioned is, I think worth to mention, is the quality proof of quality checks, because I think this can adapt some kind of the competitiveness of the company, right? Because you are able to say to your customers, look, I have all of your quality checks and validated here under your hand. Does your other suppliers do that? Like, you have the direct start point in there.